This brief tutorial is meant to show you how you might want to use this how B depends upon A activity in your classroom. The premise of this activity is that students are presented with different function rules which they have to identify, but instead of these being graphed in 2 dimensions on a coordinate plane, the input and the output values are both represented in just a single dimension on a number line. So this is sort of a novel way to test students' conceptual understanding of function rules and of inputs and outputs. The way that the activity is designed is that the blue dot here represents the input value A, the red dot represents the output value B, and the only thing that students are allowed to do is to drag the blue input dot around to test different input values for A and to see what the output value is for B. So in this case, well, in all cases, students are allowed to drag the input value anywhere between -10 and +10, and not just integers, but also obviously between integer values. In this case, it looks like the rule is fairly simple. All we're doing is we're taking the input value of A, and we're adding 1 to it to get the output value of B. So what the student would do is in the answer box here, we can see that it's using function notation B is equal to f of A is equal to A plus 1 in this example. The student clicks on am I right? And if it is correct, a little noise will sound and the student can click to go on to the next function rule. In this rule, again, presented with the input-output pair graphed on a number line, the rules also seems to be fairly easy. In this case, the student just needs to subtract 1 from the input value of A to get the output value B. So in this case, the function rule would be A minus 1. The next rule. So if students kind of think they see a pattern here, they might deduce that, well, in this case it looks like the output value is 3 less than the input value. Perhaps this rule is A minus 3. And while this is actually not the correct rule, I encourage students to kind of go with their gut feeling or with their instinct on this, because the activity will present a green dot that shows the output of the student's rule. And so even if they get it wrong, because you can see the activity here says try again, when the student drags the input value around, the student can actually see that, oh, my green output value doesn't correspond with the red output value I was supposed to have. And so perhaps the student can tell by the behavior of maybe not just the red output value, but their green output value that was incorrect, what this rule might be. So in this particular case, it looks like that we're taking the input value and multiplying it by 2. And so either 2A or 2 times A would be accepted by the system. I've created a worksheet that I found useful with my students. Depending on the ability level of the students, some of them are not able to recognize the function rule based on the behavior of the red and blue output and input dots. And so what I suggest that they do is that for each of the 16 function rules in the activity, they actually see what happens when they drag the input dot to -3 and then record the output value in this blank. And so for each of the 7 rules, students would record the 7 output values they get back for the inputs of -3 to +3. And then when they found the correct rule, they can write it in this far right column labeled f of A. So I found for most students, this helps kind of slow them down, helps them perhaps see the pattern that emerges if it's not obvious from the behavior of the dots. And then for students who still need additional help, I suggest using paper and pencil, so graph paper and pencil to actually graph the inputs and outputs on a coordinate plane, or I prefer using an online graphing calculator software called Desmos. And what students can do with this is that they can actually just type in the input-output pairs. Say, if we are looking at the example where we're taking the input value and adding 1 to it to get the output value, the students could actually just type in the ordered pairs that they see, and perhaps from this, at the very least, they should be able to see what function family this function belongs to. In this case, it appears to be linear, and then maybe they can take some of their other knowledge, such as the knowledge of slopes and y-intercepts, to figure out what the function rule is.